Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the deviation of real gas from ideal gas. The ideal gas equation is very simple and thus very convenient to use. However, gases deviate from ideal gas behavior significantly and states near the saturation region and the critical point. This deviation from ideal gas behavior at a given temperature and pressure can accurately be accounted for by the introduction of a correction factor called the compressibility factor, Z, defined as. Compressibility factor accounts for the deviation of real gases from ideal gas behavior at a given temperature and pressure. Obviously, Z equals 1 for ideal gases. For real gases, Z can be greater than or less than unity. At very low temperatures, all gases approach ideal gas behavior. The farther away Z is from unity, the more the gas deviates from ideal gas behavior. Gases behave as an ideal gas at low densities. Question: what are the criteria for low pressure and high temperature? Answer: the criteria is that the pressure or the temperature is compared with the critical value. The pressure or the temperature of a gas is high or low relative to its critical temperature or pressure. Variations of real gas compressibility factor measured by experiments. The compressibility factor is not only related to the state but also to the gases. Compressibility factor for nitrogen, for example, is: for the same substance, different states results in the different values of compressibility factor. Deviations of real gas from ideal gas are the deviation of agglomerated state, liquefaction of real gas. Under appreciate conditions, the real gas can also undergo a gas-liquid phase change, which is the difference between the real gas and the ideal gas in agglomerated state, and the ideal gas will always be in the gas state regardless of the state change. In 1863, the Dutch scientist Andrews compressed the carbon dioxide at different temperatures and correspondingly measured the P and V values at different temperatures to obtain a set of constant temperature curves on the PV diagram. Experiments shows when the temperature T is lower than the temperature Tc and carbon dioxide is compressed or expanded at a constant temperature, there is a phase change of gas and liquid. When the temperature T is equal to the temperature Tc, the line segment of the gas-liquid phase change process shrinks to a point, indicating that there is no carbon dioxide phase transition process, and Tc is called the critical temperature. When the temperature T is larger than the temperature Tc and carbon dioxide is compressed or expanded at a constant temperature, no matter how the pressure changes, carbon dioxide is always gaseous, and the higher the temperature, the more it conforms to the ideal gas law. Gases behave differently at a given temperature and pressure, but they behave very much the same at temperatures and pressures normalized with respect to their critical temperatures and pressures. The normalization is done as the reduced pressure is, the reduced temperature is, the pseudo-reduced specific volume is, the compressibility factor for all gases is approximately the same at the same reduced pressure and temperature. This is called the principle of corresponding states and will be discussed in Project 5. Okay, that's all for this task. Thank you very much, and see you next time.